Hi everyone, welcome back. Today we are solving minimum and absolute difference. So we will be given an array of distinct integers and we want to find all pairs of elements with a minimum and absolute difference of any two elements. And we want to return the list of pairs in ascending order, and for each pair, the first number should be less than the second number. So if we look at this example, the smallest difference is 1. So we'll return this pair, and this pair. In this example, the smallest difference would be 2, so we will return this pair as no other pairs have a difference of 2. And in this example, the smallest difference would be 4, so we will return this pair, which we get from -14 and -10. We will return this pair, which comes from a difference of 4 here, and then we will return this pair as well, which comes from here. So now that we have seen some examples, let's get to how we can solve this problem. To solve this problem, we can first sort the array, and after sorting, we know that for each number, the closest number to that number will be in its neighbors, so we can iterate through the array, and as we are iterating, we can calculate the difference between each element and its neighbors, since we know that will be the minimum difference to that number. And overall, we want to keep track of the smallest difference that is seen in the array. And now that we have the smallest difference, we can iterate through the array again, and this time we want to see if any pairs match the smallest difference that we saw in the first time that we have iterated through the array. Then we want to add that pair to the resulting array, and finally we want to return the resulting array as our result. So let's go over this example real quick. So this will be the resulting array we return, and this will be the variable we use to keep track of the smallest difference. So first we will sort this array, and now we will look at each pair. This has a difference of 4, so we update the difference. Difference of 6, we don't need to update. Difference of 7, we don't need to update. Difference of 5, we don't need to update. Difference of 11, don't need to update. Difference of 4, which is equal to the difference, so we keep it. And also difference of 4, so we keep the minimum difference at 4. And now that we have calculated the minimum difference, we will iterate again, and if any number matches this difference, we will add that pair to the resulting array. So difference of 4, add to result, no need to add, no need to add, no need to add, no need to add. Difference of 4, add this pair to result. Difference of 4, add this pair to result. Now that we've come to the end, we can return this as our result, and the time complexity would be O of n log n, where n is the number of elements in the input array, because it will take n log n time to sort through this array, and the space complexity will depend on which sorting algorithm we use, but I will be using the built-in Python sorting method, so for me it would be O of n space. So now let's get to the coding part. So first we can sort the array. Now we will set the result as an empty array in the beginning. Now we will initialize the difference as infinity in the beginning, and now we will do our first iteration through the array. So for I in range length of array -1, and we will keep track of the minimum difference, so it will be the minimum of difference and array of index plus 1 minus array of index. Now that we have the minimum difference, we will iterate again for I in range length of array -1, and now if any of the difference is equal to the minimum difference, so if array of I plus 1 minus array of I is equal to the difference, then we will append that pair to the result. So it will be array of I and array of I plus 1. And finally, we want to return the result and see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave in the comment section, and I hope to see you all again soon.